All right, guys, let's begin. So let's talk about the first one. Now, yes, this time there's a red dot on top. Yeah. There's a red dot. It's there. Okay. So, all right, guys. So, like a lot of you, for question number 1 here, it says square root of 4 times square root of 5. And some of you just wrote the answer under it because your calculator does it for you. And if I saw that, I just marked it as wrong. I wanted to see either you went like this. Some of you did this. You go, oh, this is just 2 times square root of 5. And I accepted that as long as I felt like you did it that way. But some of you went further. Like some of you went like you're acting like robots and you went square root of 20. And then you broke it down again and you're like, oh, we're back where we started. It's just 2 square root of 5. So very few people got that one wrong. Some people did though. Okay. So let's just leave it at that. Now, number 2, it says square root of 7 times square root of 12. There was tons of people just writing the answer like it's obvious. It's not. For some of you, might be obvious, but I would have liked to have seen square root of 84. And then you would have broken down square root of 84. Now, the way I did it would be something like this. I look at it, I'm like, okay, I can break this one down to this. And then this is square root of 7 times 2 square root of 3. And so this becomes 2 square root of 21. But if you just wrote 2 square root of 21, and you didn't justify it, I marked it wrong, which I think it's fair. Okay, you can't just write answers that your calculator gives you because that defeats the whole point. So 3, it says 3 square roots of 8 times 4 square root of 7. So that's going to be, well, I would work it this way. There's a bunch of ways to do it, but I would just kind of like say, okay, this is 3 times the square root of 4 times the square root of 2. I'll put the x there just to separate them, but I can't do anything with 7, really. So you got 3 times 2 here, times the square root of 2, times the 4 square root of 7. So that's 6 square root of 2 times 4 square root of 7. So that's 24 times the square root of 14. Can't really break down 14. Square root of 14. So I'll leave it as that. Let's go ahead and go to problem number 4. I'll do it under 1 just to, oh, no, don't do that. So number 4, 2 square root of 3 to the 4. So some of you just wrote the answer, unacceptable. It should be something like 2 to the 4th, square root of 3 to the 4th, like that. And then there's many ways you could have proceeded, but 3 times 3 is 9, times 3 is 27, times 3 is 81. So it's 2 to the 4th times the square root of 81, which is 16 times 9, which last time I checked was 144. Okay, so far, so good. Number 5, square root of 62 divided by square root of 2. Some of you wrote the answers, but I should see some justification using the rules we learned. Like, for instance, that could be written like that. And then this is just a square root of 31. And you can't do much with square root of 31. Now, I need to stop here and just ask you guys any questions that I need to elaborate on. Because, some of you are just going to write down your notes, and that's fine. And some of you don't want to ask questions in class, and I understand. And you're just going to hopefully go home and just go through this. Now, yes. Yes, you're allowed to do it. Even if you can't, you're allowed to represent. Like, let's say you can't divide this. Let's say you can't divide this. Sorry, I just wrote it. Wait. Let's say you had this, right? You can re-represent that as this, even though you can't divide it. But you can write it as a decimal if you like. You see? You're allowed to go back and forth between those. Does that make sense? Okay, good question. Any other questions? Okay, so let's continue. So number 7. Oh yeah, you can't do anything with 6. So number 7, you got square root of 80 minus square root of 4. I'm going to close that door because for some reason these kids are obnoxious. I can do them. It's like they're trying to be purposely obnoxious. Okay, so square root of 4 is 2, right? So automatically I'm going to go, okay, what can I do? Well, 16 times 5 doesn't work. Does 16 times 5 work? Yes. Square root of 16 times the square root of 5 minus square root of 4 is 2, so I can just write it. And you have 4 square root of 5 minus 2, and you're done. Nothing else to do there. Nothing else to do there. So as you can see, not a much thinking, but it'd be nice if you could understand this. So let's continue. Let me scroll up a little bit. I'll go ahead and just push this all the way up. So we're gonna go do 8. Well, I skipped 8. So 9, let's do 9. We got 4 square root of 8 divided by the square root of 24. Lots of way to do this, but one of the ways would be you could do rationalize the denominator, but you could just rewrite this as 4 square root of 8 over 24, which is 4 square root of 1/3. Well, we now know that 4 square root of 1 over square root of 3, but this is just 4 times 1 over square root of 3. And then we're just going to rationalize the denominator by multiplying both numerator and denominator by the square root of 3. That comes out to 4 square root of 3 divided by the square root of 9, and we know that the square root of 9 is 3. So it's just 4 square root of 3 divided by 3. There's other ways of doing it, but that's one of the ways. And I'm justifying each step. Obviously, when you're taking your test, if your calculator just does it for you, that's great, but not on this test. So 27 divided by the square root of 4. Well, here, obviously, it's just going to be 27 divided by 2. If you try to rationalize it, you end up with the same answer. Now, 11. Here come the easy ones. A lot of people did just fine on these. So I made the test so that if you miss the first 10, you still got a C. You know, that's how I figure. I said, you know what? If they can't do square roots, but they'll still get a C on my test. So if you're getting an F, that means you know nothing. But if you're getting a C, that means you know the ones that I really care about you knowing, which is 11, 12, 13, you know. So x to the 13 is the answer to that. You just add the exponents when you multiply numbers with the same base. Number 12, right here, it's going to be a to the 8th times a to the negative 2nd times a to the 9th. Well, all of them have the same base, which is namely a. A plus negative 2 is 6 plus 9. That's 15. So you just end up with a to the 15th. 13, you have b to the 3rd to the 2nd. You know that's going to be b to the 6th. Oops, I wrote a 6 there. B to the 6th. Because you multiply the exponents, right? And number 14, you have x to the 7th, y to the 2nd to the 3rd power. So you have x to the 21, y to the 6th. And make that better, a better looking 6 there. And then you got 15, which says 16 h to the 10, and I'm going to write it in fraction already, 8h to the 3rd, so divided by that. So 16 divided by 2 is 8 is divided by 2, and then you got h to the 7th, because in this case, you're going to subtract the exponents, as we know from our rules. 16, now we have some of these more complicated looking stuff, but they're not. When you have parentheses like that and you take it to a power, we agreed that we're going to multiply the exponents. So you have 2 to the 2nd, remember this is to the 1st power here, m to the 6th, n to the 10th, times 3 to the 4th, m to the 4th, n to the 12th. And now you do some math. 2 to the 2nd is 4, m to the 6th, n to the 10th, times 3 to the 4th is 81, m to the 4th, n to the 12th, right? And then you multiply them. 81 times 4 is 324. M to the 6th times m to the 4th, that's m to the 10th. N to the 10th times n to the 12th, that's n to the 22nd. Agree or disagree? Super easy, right? I think the test was fair. You have somewhat of a smile. Okay. Yes, it's like the Mona Lisa smile. It looked like that one. Like you can't really tell if she's smiling or smirking or I don't know. All right, so number 12. Well, no, number 17, sorry. 17 was 3 to the negative 3, which is indeed a negative power, means it is a positive power denominator, but you got to remember that 3 times 3 is 9, 27. Small mistake. I make those mistakes too, arithmetic mistakes. We all make them. 18, we got 8 to the 1/3. Well, that is indeed the third root of 8, which is just 2. Or you could have done it this way, which is you represent 8 as 2 to the 3rd raised to the 1/3. See, 2 to the 3rd is 8. Then you apply the rule that you multiply exponents. That's 3/3, which is 2 to the 1st, which is 2. Same answer. Then you have 19, which has 1 over 25. Let me close up email there. Oh no, email closed. 1 over 25 to the half. That's just really 1 to the half, 25 to the half, which is square root of 1 over square root of 25, which is just 1/5. 20 says d to the 4th to the 3rd is equal to d 4/3. You could just multiply 4 times the 3rd. Right? So, you know, I mean, I don't know what to say. But
yeah, for 20, we did as if like we had to proceed.
so for which one? For 20?
Yeah, so if I put like 3.
Okay, if you went like this, yes. So if you went 3rd root of d to the 4,
yeah,
would you be incorrect? You're awesome, you're fine. There's many ways. There's many ways. As long as you're correct. Don't get yourself in trouble and be incorrect. But in your case, yeah, there's no way I can mark it wrong. Like, it would be wrong for me to mark that wrong if you wrote it that way. Now, obviously, the last few questions were just to state the rule. So here's the multiplication rule with exponents, right? Guys, I hate thinking of them as rules. They're more like self-evident things when you obviously explore what each of these things mean. So when we divide them, we subtract the exponents. Remember, they have to have the same base. Then when you have it raised to the power in parentheses, we're just going to go ahead and multiply the exponents. 24. X raised to the m over n is the nth root of x to the m. 25 x to the negative m over n is the 1 over x to m divided by n, which in turn is 1 over the nth root of x to the m. Now that I finish this, I need to state something obvious. There are some of you here who are contemplating leaving the class. I will tell you that that is the wrong course of action. The correct course is to not quit when things are tough. Your interest should not be in the result of the grade. Your interest should be to work on things that are difficult in spite of the results. If every single time something is difficult, you just walk away, you're closing doors that you would never, ever know that they're there. Just because you're worried about an extrinsic thing like a grade, instead of coming in here, trying your best. That is super duper important. I cannot emphasize more how important it is not to quit when things are tough. Usually when things are toughest, it's then gets easier after that, but you never know. It's like getting over the hill, the final part of the hill or mountain, then it should be easy after that. So that's my the first part.